Okay, so it is day 24. We are in Unit 3, Inequalities. Here was our do now, and let's look at our answers. So for number 1, I have the number sentence that says 2 times n is less than 10. So what did you guys write for the inequality? Good. Good, so I've got 2 times n, so I could write that as 2n. And then what? Is less than, good. So I did this. 10, just the number 10. All right, did you guys all get this correct answer? Good. All right, well, that's all right. You got in here a little late. So now we have our written out inequality. 2 times n is less than 10. So we're going to solve for n. What would I do first? Yes, to get rid of multiplication, we divide. So I'll divide by 2 on both sides. And I'll get n is less than, 10 divided by 2 is? 5. Good. So for my next step where I said solve for n, all right, n is less than 5. Okay, now I've just got to draw my graph. So how am I going to label this graph to show that n is less than 5? Yep, we're going to label our tick mark with the number 5. Circle it. Do I shade it in? No. 5 is not included. And which direction do I shade? To the left. Good job, guys. That's perfect. All right, any questions about number 1? We all feel all right about it? Good. Okay, let's look at number 2. Number 2 says n plus 5 is greater than or equal to 12. What did you guys write for number 2? N plus 5. So greater. Ooh, yeah, since it says greater than or equal to, we've got to make sure that we include the bottom of that symbol. So n plus 5 is greater than or equal to 12. 1, 2. Perfect. All right. Now I need to solve for n. So what should I do next? Yes, good. Subtract 5 from both sides. 5's will cancel. I'm left with n is greater than or equal to 12 minus 5? 7. Good. So to solve for n, I got n is greater than or equal to 7. Good. Any questions so far? Does everybody feel okay about getting to this answer? Good. All right, how am I going to draw my graph? Yep, I'm going to label my tick mark with the number 7, and then what? Circle it. Yes, because it's greater than or equal to, that means n can be 7. So we're going to shade 7 in. And which direction do I shade? To the right. Because it's greater than. So this is any number bigger than 7. All right. Any questions for number 2? Okay. Yeah, 3 is a tricky one. I threw in something a little bit different for number 3. So let's look at number 3. It says -1 plus 10 times n is greater than -1. So let's just go one step at a time. I see -1. So what should I write down here? Perfect. -1. And what next should I underline?
Plus 10.
Sure, plus 10. There we go. What's next? Times n. So there's two things I could do. I could just write a multiplication sign with an n, or I know that whenever I see 10n, that's also 10 times n. So I could just write it like this. Is everybody okay with that?
Yes.
Okay, good. All right, what's next? Good. Is greater than. And what's the last part? -1. Good. How'd you guys do with that one? Good. I know it looks a little tricky, but again, step by step, and you guys got it. That's awesome. Okay, what's my first step?
You're gonna add 1.
Yes. Let's get rid of that -1. So we'll add 1 to both sides.
Cancel out the 1.
My ones cancel.
Bring down the
10n is greater than -1 plus 1. What's that?
0.
0. Good. Okay, now what?
I got that wrong then.
That's all right.
I'm like,
So,
I forgot you said don't make a 0.
yes. So if I have -1 and I add 1, like if I owe somebody $1 and then I pay them that $1, now I owe 0. Good. Hello, hello. I love your hair. It's so pretty. Right. Okay, so now we have 10 times n is greater than 0. So what's next? Yeah,
okay, that's what's
we're going to divide by 10. I know, sometimes when we get zeros, it makes us want to stop because it's like, I must have done something wrong. But you didn't. You didn't. So our 10s will cancel. And I'm left with n is greater than, if I take 0 and I divide it into 10 equal parts, how many am I going to have in each part? 0. 0 divided by anything is 0. So we got n is greater than 0. Okay. Did any of you get to this n is greater than 0, or did we get scared and stop right there?
I got it now.
You got it now. Good. Good, good, good. Okay. So now that we have our n, how are we going to graph it?
We put 0 above the tick.
Yes, we're going to put a 0 right there.
And just circle.
Circle the tick mark. And what direction do I shade?
Nothing.
Well, n is greater than 0. Yes, I know 0 makes us think that we do something different, but it's just a number.
Okay.
Just another number. All right, guys, here are those answers. Before we move on, do we have any other questions? Okay, and guys, if any of you at any point are feeling like you're not getting everything down fast enough, like writing it down, see me after class. I can make you copies of my notes if you ever want that. Okay, I'm going to move forward.
Did you make a copy of that lesson last week that we asked you to?
I feel like I did. If not, I can do it right after class real quick.
Y'all have to run. I got no clue.
Oh, it's all right. It's all right. Okay, guys, I'll leave that up there for just a minute, but we're going to talk about what today's topics are. So, we did a little review of solving inequalities, and we're going to do a little more review after that. We're going to make sure that we understand how to do those two-step or multi-step problems, kind of like what we did here with the -1 plus 10 times n. Whenever we have more than one operation, we have to make sure that we remember what order to do those in. And then we want to go over some of those exceptions we talked about, where you might see distribution in a problem or a fraction, just like when we were solving equations. And after we do that, we are going to talk about something new. This will be the last new thing we learn in Unit 3, Inequalities. We're going to learn about compound inequalities. They sound a lot scarier than they are. So I'll let you guys take a minute to finish writing if you still are. And I'm going to pause this recording and we'll start up in a minute. So let's go ahead and look at some of our review, solving our inequalities. Let's look at number 1. Can somebody read number 1 to me? What does that problem say? Perfect. N divided by 8 is greater than 1. So we need to remember that anytime we're solving an inequality, we're solving for the variable, which is n. So here's a little note here. Our goal is always to get n by itself, and we do that by using our inverse operations. And this is just review of our inverse operations. Anytime I've got addition or positive numbers, I reverse it by using subtraction or negative numbers. Anytime I have multiplication, I can undo it by using division, and those are all reversible. So if I've got division, I use multiplication. If I've got negatives or subtraction, I use addition. Okay, so now that we've got this here, what am I going to do to solve number 1? Yes, I'm going to multiply. Since I have a division problem, I'm going to multiply by 8 on both sides. All right. And what happens next? Yes, my 8s are going to cancel out, and that leaves n by itself. So I'm going to bring it down, and I've got n. What's next? Yes, I hear both of you are correct. We've got a greater than symbol, and we've got 8 times 1, which is 8. Perfect. Okay, n is by itself, so that inequality is solved. So now we need to look at how we would graph this. We just did some in our do now, but just make sure everybody feels really good about it. When I have an inequality that says n is greater than 8, that means that any number that I put into this original inequality, it will be true and it will work as long as I pick a number that's bigger than 8. So we want to show that visually on our graph down here. So how am I going to label this? Circle. What number? 8. Good. And which direction? To the right, because 8, n is bigger than 8. And this will show our bigger values. Good job, guys. Okay, let's look at number 2. This one's got more than one step in it. Somebody read number 2 to me. What does that inequality read?
3 and minus 10
Yes.
is less than or equal to negative 25.
Perfect. 3 times n minus 10 is less than or equal to negative 25. So whenever I've got 2 operations here, I've got multiplication and I've got subtraction. Which one do we undo first? Yes, we want to get rid of that negative 10. So what am I going to do? Add 10 on both sides. Great job, guys. Okay, my 10s will cancel. And I'll go ahead and start bringing things down. I'm left with 3 times n is less than or equal to. And then what is negative 25 plus 10? That's all right. Negative 15. Good, 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 good. All right, now I've got a whole new problem. 3 times n is less than or equal to negative 15. What do I do next? Divide. Divide by 3. And now we know we've got a negative 15 there. We got to pay attention to our signs whenever we are dividing our negatives. So now my 3's cancel. I'm left with n is less than or equal to, what is negative 15 divided by 3? Negative 5. Good job. All right, how am I going to graph this one? Yep, I'm going to circle my tick mark. Let's write our -5. Good. Now, is my circle going to be shaded or open? Shaded. Why is it shaded, guys? Yes, because it can also be equal to -5. So -5 is included. Perfect. And then we shade to the left because it's less. Awesome. Any questions on that one? Any questions at all? Okay, are we ready to move on to number 3? Okay, number 3, we're reintroducing those exceptions here. What do you guys notice different about number 3 that we haven't seen in the others? Yes, we have parentheses. So can I treat this normal and just start by subtracting 5 on both sides? Almost, yes. We got to get rid of these parentheses first, then we can treat it like normal. This is the exception. When we have parentheses in distribution, we have to get rid of that first. So, what should I do here? Yep, I'm distributing 2 times -3n, and what would that be?
6.
Ooh, so we have a positive times a negative. Is that going to give us a positive answer or a negative answer? Negative. Negative. When we have different signs, we get a negative answer. Good. So we'll get -6n plus... What is 2 times 5? 10. Good. Okay, so now we've done our distribution. What do I do next? Yes. Bring everything else down. Get your inequality all lined up. We want to keep it as organized as we can. All right, now I have a whole new problem. -6 times n plus 10 is greater than or equal to -2. So what happens now? Good. Subtract 10 on both sides. My 10s will cancel. Now what? Yep, I've still got -6 times n. I'll bring down my sign. That is greater than or equal to, what is -2 minus 10? Almost. -12. I know, that's a tricky one. Our negatives, they like to trick us.
Oh, I had it.
That's all right. All right. Now, we are just about to that last step. We've got -6 times n is greater than or equal to -12. What should I do? Good. We're going to divide by -6 on both sides. My -6's will cancel. And I'm left with n is greater than or equal to, what is -12 divided by -6? +2. Good. My negatives are going to cancel. It's going to give us a positive answer. Okay. So for number 3, we're going to get n is greater than or equal to 2. Any questions about how we got 2? Everybody feel okay about that one? Okay. How are we going to graph it now? Yep, we've got a 2. We're going to circle the tick mark. Shade it. Good. Because it's also equal to. And then which direction do we shade? To the right, because n is greater than or equal to number 2. Good job, guys. Okay. Okay, we've got just one left. Anybody need a minute to keep writing? Okay. All right, let's look at number 4. Number 4 is going to be another exception. What is different about this one, guys?
It's our, 3 times n minus 2 division.
Yeah, we've got a division problem on this side of our inequality. We have this whole quantity, 3n minus 2, all of it's being divided by 4. So, anytime I have something stuck at the top of a fraction, I cannot touch it until I get rid of the denominator, until I get rid of my division problem. So what do I do to get rid of that division? Yes, it's as simple as that. We're just going to multiply this whole side by 4. And whatever we do to this side, we've got to do to the other side. Okay, my 4's will cancel. So now I have what?
3 times n
Good. 3 times n minus 2.
less than 16.
Less than 16. Good job, guys. All right, now what do I do?
2 on both ends.
Yes, ma'am. You are adding 2 on both sides to get rid of minus 2. My 2's cancel. Then what?
3 times n less
Mm-hmm.
than 18.
Good. 3 times n is less than 18. Perfect. Okay, last step. What do we do?
Divide 3 on both.
Perfect. Divide by 3 on both sides. My 3's cancel. I'm left with n is less than, what is 18 divided by 3? 6. Good job. Good job. Is anybody confused about how we got n is less than 6? All right, how do we graph it?
6 plus 2.
Yep, always start by labeling our number. We've got 6. Circle the tick mark. No shading. Perfect. We don't color the circle. And go to the left. Good. N is less than 6. So we shade where the numbers get smaller. Awesome, guys. How do we feel about inequalities? Graphing them, solving them. Do we feel okay? Are we ready to go to the next thing? We're going to learn our compound inequalities. I think you guys are ready. I think you are. Okay, guys. Let's move on. Compound inequalities. Crazy stuff, guys. A compound inequality, if you want a definition, it is basically when there is more than one inequality joined together with what we call and, or. And inequalities and or inequalities. There's 2 different kinds. So let's talk about both. I am going to show you the and ones first. So we're going to make 2 little sections on this page. So I'll make the first section. Hang on, I got something on here. Oh, what's that? All right, and inequalities. And then I'm going to make a section for or inequalities. All right. So let's start with the and inequalities. Whenever we have a compound inequality, all it means is that our value for n can have more than one sort of restraint on it. So normally we would say n is either less than a certain number or it's greater than a certain number. But with a compound inequality, we might have something like this. For example, I might have n is greater than 3 and it'll literally have that word and in it, and n is less than 10. So here's an example of a and compound inequality. So here's how we would graph that. First, we're going to draw our line just like normal. And this time, instead of drawing one tick mark in the middle, because we have two different constraints here, we have n is greater than 3 and we have n is less than 10, we actually need 2 tick marks because we're comparing from two different numbers. So I'll put 1 on either side. Okay. Now, whenever we have more than one value that is constraining our values for n, we need to make sure that we put them on the correct tick marks. So if our numbers are smaller to the left and they're larger to the right, which tick mark should I put 3 on and which one should I put 10 on?
10 goes to the left and 3 goes to the right.
So 10 over here and 3 over here?
I'll put the 3 in the first tick mark.
Yeah. No, you're all right. So I've got 3 here because when I'm counting my numbers, I would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 would come next. So I want to put my smallest numbers first and my larger numbers second. Yep, now we're going to do the same thing we did before. I'm going to see that n is greater than 3, so I'm circling my tick mark and I'm not shading it in. Same with 10. I've got n is less than 10. It's not equal to, so I'm going to circle my tick mark. I'm not going to shade it in. And now I want to think about what's going to happen here. So I know n is bigger than 3, so we'll be shading to the right. So maybe I'll do something like that, make a little arrow just so I can think about it. And then I've got n is less than 10. So for the number smaller than 10, we'll be going to the left. So now what I have is 2 arrows pointing towards each other in between our 2 constraints, our 2 barriers, boundaries. So all we've got to do now is shade them in between. That's all that you do. Let's do another example. What if I had n is less than or equal to 21 and n is greater than -3. So I'll go ahead and draw my number line. And how many tick marks is this going to have? 2. That's right. We've got 2 constraints here. Okay. So I see now I have 2 different numbers here. I have 21. I have -3. Which number should go where on my graph? Right here? Perfect. Yes, -3 is smaller than 21. So the smaller value comes first because our numbers go left to right. So we're going to put -3 right here. Circle our tick mark, absolutely. And we don't shade that one, so that one's done. And then I've got 21, so I'll put that one over here. Then I'll circle my tick mark. And do I shade this one? We do. Good. It says less than or equal to 21. So 21 can be included. Okay, now I got to think about where to shade. It says that n is less than or equal to 21, so from 21, which direction am I shading? To the right or to the left? To the left, because it's my number smaller, so I know I'm going that way. And at -3, it says n is greater than -3, so am I going to the right or to the left? To the right, where it's bigger. And look at that, same thing. They're pointing at each other, so we just shade in between. And guys, anytime we have a compound inequality with and, it's always going to be shaded in between, always. And inequalities are just showing values that are facing towards each other like this. Okay, let's do one more example of and, then we'll look at or. Okay, let's do n is greater than or equal to 12 and n is less than 14. Okay. How many tick marks? 2. Good. And where do each of my numbers go?
12 goes toward the left.
Yes, 12 comes first because it's smaller than 14. So 14 must be second. All right. What kind of circles am I putting on either of these tick marks?
12 goes to 13.
Yes, 12 is going to be circled and colored in because it's greater or equal. And then 14, you're absolutely right. It's just less than. It's not included, so we leave that one open. And this is an inequality with and. I can actually look at my numbers here. I see 14's pointing this way. I see 12 is pointing this way. Where am I going to shade on my graph here? In the middle. Very, very good. That's it. It's not so bad, guys. Okay, so that is what an inequality, a compound inequality, would look like with and. Does anybody need more time to write any of these? Okay, now I'm going to show you what an or inequality looks like. So I'll give you a couple more examples. We'll start with n is less than -2 or n is greater than 9. So let's draw our graph. Okay, how many tick marks is this graph going to have? 2. With a compound inequality, we're comparing more than one value. All right. Now I've got two different numbers that I'm comparing into. I've got a -2 and I've got a +9. Which order should those numbers go in on my graph? Perfect. -2 comes first. -2 is smaller than 9, so 9 must be second. Okay, now we're going to do our circles. -2, am I going to fill that circle in or no?
No.
Nope. How about 9? Also no. Good. Now we just got to look at the direction. What direction is -2? N is less than -2. Are we going to shade to the left of -2 or to the right? To the left. Good. Because n is less than -2. So I want to shade in for all the numbers smaller than -2. And what about n is greater than 9? Good, I see you pointing to the right. There you go. You guys see the difference between the and inequalities and the or inequalities?
Yep, and you shade in the middle and or you leave open.
Yeah, that's the only real difference. And you're shading in between, or inequalities, you are shading in opposite directions. I'll give you a couple more examples to look back on. N is greater than 4, or N is less than or equal to -1. And I'll go ahead and do my 2 tick marks. Okay, what are my 2 numbers? 4 and -1. On my graph, which one of those numbers should come first? -1. That number, -1, is smaller than 4. So we want to put the number that is less first so that our graph is accurate. So I've got -1 and 4. Okay. How am I going to label this graph? Uh-huh. Yes, -1. It says N is less than or equal to -1. So since it's included, we will shade that circle in. And N is greater than 4. Do we shade this one? Nope. We leave that circle open. And what direction am I shading for both of these? Perfect. To the left for -1 and good. 4 I shade to the right. We're shading them in opposite directions from each other. We want them pointing outwards. So what this means is that N cannot be any number in between -1 and 4. Every other number, though, is included. Just none of the ones in between there. All right, one last little example. N is less than or equal to -17, or N is greater than or equal to -3. This one's tricky. I'm giving you 2 negatives. Gotta remember how negative numbers behave as we go further left to the smaller numbers. The negative numbers look like they get bigger. So for this compound inequality with or, I've got -17 and I have -3. Which one of those numbers is smaller? Yes, -17 is smaller than -3. So that one comes first. -17 and -3. Now I've got my numbers labeled. What should I do next? Circle. I'll circle both of them. And do I shade them in or no? Yes, shade them both in. They're both either less than or equal to or greater than or equal to. And what directions? Outside. We're facing outside of each other because this is an or inequality. Good. All right, that's not so bad, guys. Do we have any questions about these types of inequalities? Any questions at all? Okay. So, in these examples, I showed you a bunch of compound inequalities where you didn't have to solve for the answer. But let's say that I gave you something like this. Here is an and, for example. How about I say n plus 9 is greater than -1 and 9 plus n is less than 17. So we've got a compound inequality here. N plus 9 is greater than -1, and 9 plus n is less than 17. What would I do here? Yeah, we just need to solve the inequalities for n, and then we graph them, just like normal. So let's do the first part. How do I get rid of that plus 9? Subtract 9 from both sides. My 9's cancel. And I'm left with what? Mm-hmm. Yeah.
Oh, sorry, the greater
That's
than.
all right. N is greater than, what's -1 minus 9? -10. Ooh, let's think about it, guys. If I have -1, let me show you a number line.
Oh, it's -1, take away 9.
Uh-huh. What did you type in your calculator?
-1, take away -9.
Okay, so you did minus -9. So minus -9 would actually be like adding 9, because our negatives right beside each other cancel. So look, if we start with -1 and I subtract 9, which direction do I go when I'm subtracting? Left or right? Left. So I'm going to go back 1, 2, 3, 4, 5, 6, 7, 8, 9. And remember, negative numbers, they behave differently than positive numbers. So first I've got -1, -2, -3, -4, -5, -6, -7, -8, -9, and -10 is where we would land. That makes sense to everybody? Okay. All right, so I have n is greater than -10. All right, we're done with that part. And now we got to solve this side. What do I do first here? Same thing. I've got a plus 9. I need to get rid of it. -9. Both sides. It's going to cancel. And I'll be left with n is less than, what is 17 minus 9? 8. Good. So now I have n is greater than -10 and n is less than 8. So now we need to graph. Okay. 2 tick marks since I have 2 answers. Okay. I have 2 numbers here. -10 and 8. Which one should go where? 8 goes first? Is 8 smaller than -10?
-10 goes.
That's all right. That's all right. It's easy to forget whenever I see like a 10 and an 8. It's like, oh yeah, 8's definitely smaller, but this is a -10. Negatives are always smaller than positives. So we'll put the -10 first, and we'll circle the tick mark. Do we shade it in? Nope. Then we'll put 8 over here, and we'll circle the tick mark. Do we shade that one in? No, you don't. And are we going to shade in the middle or on the outside? I'm hearing both answers. Let's think about it. Yeah. So I'll tell you, it is the middle, but let's talk about why. So I have n is greater than -10. My n is pointing this way for -10. So I know I'm going to shade to this side, to the right side. And then I have n is less than 8. My arrow's pointing this way to the left. So I'm shading to the left for values smaller than 8. And since those arrows are pointing towards each other, we shade in the middle. All right. All right. All right, all right. Let's do I wish we had more time, guys. I feel like we always run out before I get a chance to, like, I would love to have you guys do some practice on your own before the exit ticket, and then I could look at it. We'll do one more together, and then I'll give you an exit ticket. Let's do a solving for OR. What if I gave you, let's see, here's some. Let's do 3, just kidding, 2n minus 5 is greater than or equal to -1, or 4 plus n is less than or equal to -3. Okay. What should I do here, guys? Yes, let's go ahead and solve that first inequality. We will do plus 5 first on both sides. What happens next? Good. Cancel out your 5s. And then what? Good. Bring down 2 times n greater than or equal to -1 plus 5. 4. Positive 4. When you add a negative, you're really just subtracting. That's just 5 minus 1. Okay, now I have 2 times n is greater than or equal to 4. What should I do here? Yes, divide by 2 on both sides. My 2's will cancel. And I'll be left with n is greater than or equal to, what's 4 divided by 2? 2. Perfect. All right. Let's do the second part of our compound inequality. I've got 4 plus n is less than or equal to -3. What should I do first? Good. Subtract 4 on both sides. So now I've left with n is less than or equal to, what is -3 minus 4? -7. Good. Very good. All right. So now I've got n is less than or equal to -7. All right, guys. I want to see if we can graph this one. And draw my line. How many tick marks? 2 tick marks. Good. And I'm probably going to label my numbers underneath. I didn't give myself much room. So, what are our 2 numbers that are being compared to n? 2 and -7. Which number is smaller, -7 or 2? -7. Good. So which one comes first on our graph? -7. The smaller number comes first. So -7. And then we'll circle our tick mark. Is it colored in or no? It is. It is shaded in because it's not just less than, it's also equal to. Okay. And that must mean that my 2 goes on this other tick mark. And we'll circle it. Shade it in or no? Shade it in. Good. Okay, now we got to look at our signs. It looks like for my -7, I'm going to the left because it's less than. And it looks like for my 2, I'm going to the right because it's greater than. So am I shading in between my dots or outside? Outside. Good. Is there any confusion about any part of these types of inequalities? More than happy to answer questions, guys. Okay. You want your exit ticket?
Yes, ma'am.
Here we go. For your exit ticket today, I'm giving you 3 compound inequalities. I want you to graph them once you solve, and if you are feeling a little extra fancy today and you want to try to earn a bonus point on your grade, I'm giving you an optional bonus question. If you don't do it, it will not hurt your exit ticket grade, but if you do it, it'll help it. We're getting close to the end here, guys, so extra bonus points. Not that any of you need them right now, but if you just want a little extra practice, go right ahead. Okay, and I'm going to end that recording there and get that on YouTube.